Welcome back, everybody. Today we're talking about direct variation, and our learning target is I can write a direct variation equation. So, what is direct variation, you may ask? So, a couple important terms that you need to know. Direct variation. Two variables, x and y, vary directly if y equals kx. Notice that I'm taking my input, my x, and I'm doing nothing else but multiplying it by the same number every time, which is k. And when I multiply those two together, that's how I get y, my output. Think about if you had a lemonade stand and you were selling lemonades for 25 cents a cup. The total amount of money you make, which would be your output or your y, you could find that by taking 25 cents, which would be your k value, times the number of cups you sold, which would be x. Again, the key is you're doing nothing else but multiplying your input by the same number every single time. This number you multiply by, or k, is called the constant of variation. Now there's two ways that you can think of this constant of variation. For one, it's the slope of the line in a direct variation equation. So, as x increases by 1, my y will either increase or decrease by the k value depending on whether the constant of variation is positive or negative. I can also think of my constant of variation, as we talked about before, the number the input is multiplied by every time in order to get the output. One way that we can find our constant of variation, or our k, is if we take the equation y equals kx and solve it for k. We can do this by dividing by x on both sides of the equation. That will divide these x's out, which means we can cross them out. And so k equals y divided by x. So in order to find k, all I have to do is take the y and divide it by the x. So let's do some example problems. The variables x and y vary directly. Write a direct variation equation and find the value of y when x equals 15. So let's take a look again at what we're being asked to do. We're going to have to write a direct variation equation. That means our answer should look like y equals kx. And we also know that the variables x and y do indeed vary directly, so this is possible. So let's first start by finding our constant of variation. So my k equals my y divided by my x. Since my y is 20 and my x is 4, I'm going to divide 20 by 4, and I'm going to get 5. Now, notice that since the directions said write a direct variation equation, I need an equal sign, and I also need variables y and x, so I can find out any input that I plug in, and when I multiply it by 5, what y do I get? So my final answer for the first part is the equation y equals 5x. Again, because I want to be able to take any random number x, plug it in, multiply it by 5. Now, the second part asks, find y when x equals 15. So one way we can do it, using our equation, we can put the 15 in for the x. So y equals 5 times 15, or 75. Now, we can also do this by setting up a proportion. This may especially be useful if you're trying to find the x instead of finding the y. So in this case, our first y was 20 and our first x was 4. We don't know our second y, so we'll just write y, and our second x is 15. Using the cross products property, I can solve the proportion. So 4 times y equals 20 times 15. That gives me the equation 4y equals 300. And then dividing both sides by 4, I get y equals 75. Same answer, so you are free to choose whichever method you think makes more sense to you, and that's a decision for yourself. Let's do one more example like this. So we have x equals 1.5, y equals 2.5. So let's start by dividing the y by the x to get the constant of variation. So I take 2.5 divided by 1.5, and I get 5/3. Don't just trust me on this. If you're not sure that it's 5/3, actually go take your calculator, type the 2.5 divided by 1.5 in, and then turn it into a fraction. Don't be lazy. If you really don't know how I got that, do it on the calculator for yourself. So now let's put the k value in. So my equation is y equals 5/3 x. And then, in order to find the value of y when x equals 15, we'll do y equals 5/3 times my x value is 15. And so I know y equals 25. Again, either A, you better be good at multiplying these fractions, or B, you better type this in your calculator right now and actually do it to show that it equals 25. Don't just copy what I do on here, actually do the problems so that you learn them better. Alright, or using the proportion method, set up a ratio of y to x. My first y is 2.5. My first x is 1.5. I don't know my second y, so that's y. My second x is 15. Then let's use the cross products property. So 1.5 times y equals 2.5 times 15. So 1.5y equals 37.5. So dividing both sides by 1.5, I get y equals 25. Finally, let's do a problem where we graph a direct variation equation. So let's have y equals negative 2.2x. Well, I know I can find my y value by multiplying all of my x's by negative 2.2. So let's just pick negative 1, 0, and 1 for my x's. And all I have to do to get my y's is multiply my x by negative 2.2. So negative 1 times negative 2.2, that'll be 2.2. 0 times negative 2.2, that'll be 0. And 1 times negative 2.2, that'll be negative 2.2. Now let's put them on the graph. So negative 1, that's 1 to the left, and then 2.2 up, so somewhere between 2 and 3, but closer to 2. And then 0, 0, and then positive 1, so 1 to the right, and 2.2 down. So between negative 2 and negative 3, but closer to negative 2. Let's connect the dots. And there's our graph. all you got to do. Pick some x's, multiply them all by your constant, and then connect the dots. So that's how you do direct variation. Now go do some practice problems.